All right, chemists, we are in our very last section called functional groups. And so as a result of watching this video, you should be able to explain the significance of aromatic compounds. You should also be able to name alcohols and amines, and then identify primary, secondary, and tertiary alcohols and amines, identify organic functional groups, and identify the structure of carbonyl compounds. So let's first talk about aromatic compounds. These are compounds that are very stable due to their overlapping p orbitals and resonance. The simplest aromatic compound is benzene. So it's C6H6, and we can show it as alternating double and single bonds, or you can show it with just kind of like a hexagon with a circle in the middle. That's a very common way of showing benzene. This contains unsaturated bonds. Remember, if it's all single bonds, then it's considered saturated. So this contains unsaturated alternating bonds and are said to be conjugated. Now, in terms of talking about functional groups, there are hydrogen atoms on the carbon that can be substituted with different groups. So they're very similar to a lot of patterns that we see in organic chemistry. And so there are many rules that encompass naming functional groups, so we're not going to focus on all of them because there's a lot. You'll definitely learn about that in organic chemistry if you take that in upper level chemistry classes. But we will focus on how to name two easier functional groups, the alcohols and the amines. So first, with alcohols, we can identify them because they contain hydroxyl groups or OH groups. To name an alcohol is very simple. You have to determine the parent chain, just like we did before. The parent chain must be the longest chain that includes the carbon containing the OH group. The chain is numbered to give the hydroxyl group the lowest possible number. You have to change the parent chain ending to OL. So for example, if we were to name alcohols, remember we've got the OH on the end there, so that's not a carbon, that's an OH. So the first one, in this case, because we've got a methyl group, this will be methanol. The second one has two carbons there, so this is going to be called ethanol. And for this one, we have three carbons and then a substituent. So this is going to be 2-methyl, 1-propanol. This example is important because notice that the hydroxyl group, that OH, is given priority. So that is what is incorporated into the parent name. So you want to make sure that you assign the 1 to the propanol, and then the methyl group can obviously follow suit. Next up is talking about whether we have primary, secondary, or tertiary alcohols. So again, we're looking at patterns in these structures, and alcohols are usually classified by the number of carbon atoms that are bonded to the carbon atom that have the OH group. So for example, in the previous example that we saw with methanol, this is called a primary alcohol because it's connected to one other carbon. This one is called a secondary alcohol because if you notice, we've got that carbon connected to two separate carbons in that kind of Y-looking structure. And then for the last one there, this is called a tertiary alcohol because the carbon is connected to three separate carbons around it. So we can do the same thing for our amines. So you can recognize an amine because it contains nitrogen, nitrogen and hydrogen, or nitrogen and 2 hydrogens attached to a carbon. The same rules apply for alcohols, except instead we're going to add the suffix amine to the longest chain. So in this case, this is what we call a primary amine because it's connected to one carbon. And this is called methylamine because it's just one carbon, methylamine. Next up, we have a secondary amine. It's connected to two carbons, so guess what? It's dimethylamine. And then finally, our tertiary amine is going to be called trimethylamine. So now we have to take a look at some of the patterns that we see in our functional groups. So we've talked about alkanes as just being single bonded carbons. We've talked about alkenes as being double bonded carbons and alkynes having triple bonds. Now comes the amines, which we talked about containing NH, right? An NH group of some kind. And then the R that you see there represents any length of a hydrocarbon chain. The alcohols are very similar in terms of the fact that it contains OH, and then R again represents any length of a hydrocarbon chain. Ether is up next. This one is new. So for an ether, what you're going to see is an oxygen with 2 corresponding R groups on either side. Notice I did omit the unshared pairs of electrons on the oxygen. They are there, they're just not there in this image. Aldehyde is up next. This is a carbonyl containing compound. So what's a carbonyl? A carbonyl is basically where you see a group where it's oxygen double bonded to a carbon atom. So the majority of these functional groups contain these carbonyl groups. So aldehyde is one of them. Next up, we have a ketone, which also contains a carbonyl. But notice we've just substituted the hydrogen for the aldehyde with another R group. The carboxylic acid also has a carbonyl. Notice that we have an OH on the end there. The ester has a carbonyl. This one's a little hard sometimes to see, and a lot of students tend to mix up the ester and the ether. So ester has the carbonyl group with it. Looks a little bit more complex than the ether. So that's that. And then the last but not least is the amide, which also is so confusing because it sounds like amines. I know it's going to be rough, but you'll memorize this. So with the amide, you'll see that we have the carbonyl again, but it's connected to an R group and then NH2. These are definitely something that you're probably going to want to memorize depending on your teacher's instructions. I know that I have my students memorize these and then identify the structures on their quizzes and tests. So here's an example of a type of question, real basic example that you would be asked to do. So identify the functional groups that these molecules belong to. So the key is looking at whether or not it contains a carbonyl. That's the first thing. So I noticed that the first one does. And then I also noticed that it's attached to 2 carbons. So those are the 2 R groups. So in my mind, I'm actually picturing what my summary was. And I saw that whenever I have a carbonyl connected to 2 individual R groups, that's a ketone. Next up, I see that I have a carbonyl. And then I have a nitrogen group with 2 separate carbons off of it. So that is not our amine, that's our amide. In the upper right, I have a carboxylic acid, and again, I notice I have a carbonyl group connected to an oxygen and a hydrogen. That's an acid. And for this last one, notice the absence of the carbonyl, but we've got 2 R groups hanging off of that oxygen there, and so this is our ether. So that is it, chemists, for our unit on organic chemistry. You'll have plenty of practice in worksheet 5. Make sure you commit those functional groups to memory. Thank you so much for watching.